Greetings and welcome, ladies and gentlemen. Today we're talking about properties of exponents continued. Oh, yeah. So you can just tack this onto yesterday's notes in sus cuadernos. Classic. So what I want you to do is consider the following. We had this happen just a moment ago. We had x to the third over x to the third when we were doing our homework. And how could I simplify that? X? 1?
Yeah, 1.
Well, let's think about this a couple ways. Why do you say 1?
Because technically 1, it would be 1x cubed, right? It would be...
Okay.
It's x to the 0 power and anything to the 0 power.
So you're slow down. We're getting there. We're getting there. You're pulling in some rules from a moment. But let's see. What is 5 divided by 5? What is 10 divided by 10? Pi divided by pi. 10 to the 79th power divided by 10 to the 79th power. X to the third divided by x to the third. Right? I mean, this is divided by itself, so it should cancel out. Unless, well, actually, no. In this case, it still should work even if both of those were 0, because we'd technically be dividing by 0, and that would be complicated. 0 divided by 0 kind of is a little bit abstract. It requires, well, never mind. I won't even get into that all right now. But let's consider this a couple ways. This could have been x times x times x over x times x times x, right? And then you might have been like, oh, this one cancels out with that one, and this one cancels out with that one, and this one cancels out with that one. And they all cancel out. And then what would be left over? 1, which there was like the little invisible 1 that was hiding there the whole time, remember? Classic. The other way you can think about it is, oh, x to the third just cancels out with x to the third, which is 1. The other way I want you to think about this is using our properties of exponents. This is what one of the students was alluding to. Dividing two things of the same base, we did what with the exponents? Subtracted them, so I get x to the 0. But if this cancels out and equals 1, and if it's also equal to x to the 0, that means x to the 0 equals 1. Peculiar. Unusual. Alright, so there's our next property. This is 0 power property. Which says that if the power lines go down, your property will have 0 power. I'm hilarious. Let's see, a to the... Oh, that's awesome. I'm leaving that right there. That was actually E, the letter E, Euler's number. That's approximately 2.718281828. So no, I didn't spell it wrong. I was just throwing some other numbers in the middle of that word. I think it's because I pluralized it up here. I get confused. Classic. Let's see, a to the 0 equals 1, I believe, except for a equaling 0 technically, but we won't even worry about that right now. So there's our first property. The next thing I want you to consider, what if I've got x to the second divided by x to the third? Well, right, okay, so according to her logic, well, let's watch. X squared is the same as x times x. X to the third is, man, that's like, look at that face right there. That's like a guy that just died because he was thinking about the size of the universe. And then x times x times x. And now it's a guy that just died that has like a sweater that his grandmother knit him. I like that sweater, actually. I should wear one like that for Christmas. So anyways, x times... I don't know what's up with me today. I'm sorry. Let's see. This would cancel out with that one. This would cancel out with that one. And I'd be left with what upstairs? What in the numerator? 1, because there was that 1 hiding there the whole time. You didn't spot it. It was hiding. Over x. So well done. 1 over x. Right? However, what if I did the same thing using our subtracting exponents thing? I would do x to the 2 minus 3, which is x to the negative 1. And according to this, if this is equal to that and this is equal to that by the transitive property of equality, those would also equal each other. Transitive property of equality says that if A equals B and B equals C, then A equals C. So that means x to the negative first power is equal to 1 over x. Or maybe better yet, 1 over x to the first. So here's our negative exponents. Oh, you got this, man. You got this. Look I even spelled property right. I was able to learn. You can learn too. Learn to spell property. So let's see. Negative exponents. If I have a to the negative mth power, turns out that that's the same as 1 over a to the mth. Okay? That's a good property to know. So that would have helped us do that one homework problem that was in the previous video. So we've got that. That's nice. 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 What question?
What?
I'm sorry, I was just saying nice like Marcus Phoenix would when he gets the active reload. Anyways, don't worry about it. So there's some negative exponents. One more thing I want to point out, I'm just going to throw this property to you, is power of a quotient property.
Is that not same property?
No,
Why are you knowing it before?
this is a new property, but I'm not going to derive this one for you. If I have a to the m over b to the n, all raised to the pth power, this is related to a property we had yesterday, in which it's related to power of a product property. What do you think we could do here? Yeah, it turns out exponentiation is distributed over division as well as multiplication. So that's a to the mp over b to the np. Right there. One thing I want to point out, super failure mode right here. A plus b all to the p is not equal to a to the p plus b to the p. All right, that's true for plus or minus. All right, bless you indeed. This is something that calculus students will get wrong. All right, this is like something that it's super tempting. People are like, oh, I just distribute this over the plus sign, right? No.
Look at that slide view, so you can see the A and the B. Oh, yeah.
Like this guy right here.
Yeah.
And he's got like this little haircut right there and ears.
What does it mean? That haircut doesn't mean what you mean.
Well, his eyebrows probably helped at that too. But yeah, that's a good face right there. But I just want to point out, you cannot distribute power over addition or subtraction, but it is distributive over multiplication and division. Okay, let's do this little thing real fast. Yeah, I'm using green for my properties to make them just stand out. That's all I was doing. But yeah, you are correct. We're in the orange zone. Hay naranjas en la cabeza. That's what Spanish Bumblebee, the character from The Simpsons, said once when he opened a cabinet and a whole bunch of oranges hit him in the head. True story. Let's see. I think I just lost my writing tablet. So let's consider making a table of powers of 2. The power of 2. Let's see, do I got signal yet? Oh, come on. Here we go. All right, I'm back. That was scary. I had to plug in my tablet. So let's make a table of values here. Let's say I've got, I don't know, table of values. Don't you think it's great when your table is able to evaluate? Let's have some powers of 2. Let's do like, I don't know, 2 to the x equals something. I don't know. So let's have stuff like, let me start in the middle here. We'll have 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, etc. And then we'll have, well, let's actually figure out what is 2 to the first equal to. 2 to the second is 4, 2 to the third is 8, 2 to the fourth, 16, 2 to the fifth would be 32, 2 to the sixth would be 64, 2 to the seventh would be 128, 2 to the eighth would be 256, 2 to the ninth would be 512, 2 to the 10th would be 1024. 1024 is the number of bytes I think that make a kilobyte. 1024 technically. Computers, by the way, work with powers of 2 for most of their memory storage, primarily because computers store zeros and ones, which have only 2 possible outcomes. So that's why memory and storage and computer are all powers of 2. Now, question, what's the relationship between some of these? What's going on from here to here and here to here? Doubling, doubluve, right? Or, contrary, what's the relationship going from there to there, to there to there, to there to there? Dividing by 2, right? Okay, makes sense. Makes sense. So if I asked you what is 2 to the 0th power, according to this pattern, 2 divided by 2 is 1, right? Right? By the way, I just think 0th. Or would it be 0th?
Yeah.
Zeroth?
No, it's definitely no.
Well, we have to make the O, so it's 0.
Well, anyways, nonetheless. What would 2 to the negative 1 be?
Negative 1 over
Negative 2? No. In fact, it's going to be positive.
4.
No.
1/2.
1/2. What? Right? According to this, I just divide the previous step by 2. What's 1 divided by 2? 1/2. What's 2 to the negative 2? 1/4. Then 1/8. 1/16. Right? 2 to the negative 5th would be 1/32nd. Then 1/64th. 1/128th. 1/256th. 1/512th. 1/1024th. 1 over 2056. Right? It would just keep going like that. But what I want to point out is 2 to the negative 1, that's the same as 1 over 2 to the first, right? 1/2. Which is, and this is the same as 1 over 2 squared. 2 squared is 4, right? 1/4. So negative exponents do not make things negative. They flip. They reciprocate. Okay? Is what I want to point out. 1 over 2 to the third. 2 to the third is 8. Okay? So that's some good knowledge right there to remember. So I just think sometimes this table can help us with our understanding of 0 exponents and negative exponents. Now let me tell you a story. This is how I simplify fractions. All right, here we go. Here we go. Ready? Let's say here's a fraction bar. Let's say I've got x to the negative 3, y squared, and z to the, I don't know, negative 1 or something like that, right? And here's our story, right? You are a landlord of an apartment building. There's your apartment. Your apartment building has 2 stories. All right? And you've got some tenants living in your apartment building. And some of them are happy and some of them are unhappy. How sad. It turns out y squared, he's got a positive exponent. So he loves living on the 2nd floor. He's like, man, you don't understand. I look out my window. I've got a view of like the mountains. And he loves living on the 2nd floor. And he wouldn't have that if he was on the 1st floor because it'd have like a view of like, I don't know, like a dumpster or something like that. This is my sad dumpster. And he wouldn't want to live on that floor. Right? So Y is happy living where he is. So as a landlord, are you going to kick Y out and make him move downstairs? No, Y's happy. Leave him alone. However, X, oh man, let me tell you about X. X is so sad. X is like, every time I come home from the store, I have to carry my groceries like up all of these stairs, and it's all like, and then I have to go back down, and then back up, and back down, and back up. He's like, I hate living upstairs. So what's a good solution for X? Yeah, let's just move X downstairs if he's complaining so much.
Z lives downstairs.
Yeah, but maybe there was another apartment in the downstairs we didn't tell you about.
Or they can trade.
Oh, but then Z starts complaining to you as well. Yeah, it might be what Joey's suggesting here. Z starts complaining. He's like, man, I'm telling you, why? Like, every night until 1 in the morning, dude's playing Guitar Hero World Tour, and he's playing the drum set, and all I hear is boo, 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 on my ceiling, like, all night long. It's like, what's up with that? Well, but at least it wouldn't be on his ceiling. Like shaking his chandeliers because he's a chandelier collector, right? Obviously. I mean, seriously, Z is a little bit of an eccentric guy. So where's a good thing? What's a good idea for Z? Move him upstairs. So let's see. Here's our new building, right? So what happened to Y? Y stayed the same. Y's happy. What happened to X? Downstairs. Is X happy downstairs? Yes. In fact, he likes having his ceiling shaking every day. He loves it because it helps him, pickle the cucumbers in the jars. It helps the oxygen oscillate from the grocery store that he bought all those pickles. I don't know. I'm trying to think of why someone would like that. And what happened to Z? Z's living upstairs now, and he's got a positive outlook on life, so he's got a positive exponent. Right there. Except that one, we don't even have to write it. It's just implied. Okay? So there's one story. Here's another story. Get this? Ready? All right. Let's say this is even better. Let's say I've got x to the negative 3, and let's say I've got x to the 4th living downstairs. And let's have let's just start with that. Let's just keep it simple, right? Why not? So it turns out. Right, here's our apartment building. Oh, our apartment building's blue this time still. Right? And so tell me a story here. What's going on? So turns out upstairs X doesn't like living upstairs, do they?
We didn't like living upstairs last time.
Oh man, X is always complaining about the upstairs. But the X downstairs is happy, right? So they're not going to move. Now catch this. It turns out that one day, when they were hanging out on the front porch right here. There's a little porch. This is the porch on my house, I guess. Right? They're hanging out on the porch and they see each other and guys, it's true love. They fall in love. Wow. This is wonderful. You're like a little matchmaker landlord now. What? And they fall in love and they start playing Rock Band World Tour together. No, I just mixed that up. Guitar Hero World Tour and they're hanging out all the time, and then they get married, and they're like, hey, landlord, can we move in together? And you're like, yeah, I guess. I can't make you not move in. That's your choice. And they're like, which apartment should we move into? They're trying to figure it out. And my suggestion would be that, right, they realize that this guy, he's actually crazy in debt here. And he doesn't have a lot of stuff. But X to the 4th living downstairs, she's got a lot of stuff. She's well-to-do. And it would not make sense to move the person, all of X to the 4th stuff upstairs, because there's so much of it, and we're lazy. We'd rather move just the very few stuff downstairs from that one, right? So that's what we're going to do. So we're going to move that downstairs. So we'll have X to the 4th downstairs. And what do I do when I'm dividing? I subtract exponents, right? I'm going to subtract a negative 3 here. And what is 4 minus a negative 3? That's the same as 4 plus 3. So that's x to the 7th, and it's positive, right? So my suggestion here is move the little guy to the big guy. All right? If I moved the x to the 4th upstairs, I would have had x to the negative 3 minus 4. I would have gotten a negative exponent, and then I would have had to do a whole other move. Because they would have realized, they moved upstairs, they moved in together, and then they were unhappy on the 2nd floor, and they had to move back downstairs. Who wants to move all that furniture twice? Now, guys, this is really interesting. It turns out, so you've got a vacant apartment upstairs.
Wow, it's going to be occupied by one.
Yeah, it turns out this hobbit that's invisible is like this creepy homeless guy that is always looking for vacant apartments, and he snuck in through the fire escape, and he's like living for free up there now. And yeah, and you're not making any money off of him, so it's kind of sad, but whatever. Actually, what's even weirder is that there's like this even creepier hobbit that was hiding here the whole time. He's living in the closet and not telling them. Wow, that's really sketchy. Ugh. But yeah, so it turns out one is living upstairs because everyone moved out. So yeah, of course they're going to sneak in through the fire escape. Why not? So this is kind of my little analysis for how I deal with fractions of all sorts of properties of exponents and such. You know, move the little guy to the big guy, I guess, is my little catchphrase for here. Move little guy to big guy. Right?
Turn off the light. You don't look at my Stop.
I don't know this song. Is it the Move the Little Guy to the Big Guy song?
Yes.
Oh, wonderful. I didn't realize I was infringing on a copyright. I thought it was my own quote. And as a matter of fact, I was planning on making like a Mr. Waddy action figure. And it was going to be like pull string, kind of like Woody from Toy Story. And like one of the things that when you'd pull the string, I would say would be like, move the little guy to the big guy. I don't know, what else would I say? What are my catchphrases, guys? Break it up. That would be another perfect catchphrase right there. Yeah. Do I? Oh, I didn't realize that. Sometimes I used to say check this out a lot.
Check it out.
But I don't know if I've been doing, I don't,
Say
consider, I do say consider. Yeah, but that would be a pretty great little pull string action figure.
I would buy it.
Classic? Oh, okay,
Oh, yeah.
there you go. So anyways, thanks internet friends for watching. If you're a landlord, keep your tenants happy. Bye-bye.